Hi, good morning, dear students. In today's class, we will be dealing with isomerisms. So, in the first class itself, what I said is there are two unique characters of carbon. One is catenation, and other one is isomerism. So, we will be dealing the second unique character of carbon, that is isomerisms. So, what are these isomerisms, and what are the types we have? We will see everything, right? So here there is one word, that is iso. Iso means same. So these are the organic compounds having same molecular formula, but same molecular formula, but differ in their physical and chemical properties. Physical and chemical properties. I think it is not visible. So now iso means same, merism means it is a process, right? So same, they must and should have same molecular formula. What is molecular formula then? Right? So we will see one by one, right? Each and every term I will define you don't worry. So same molecular formula they must and should have, and but they must be differ in their physical and chemical properties. Right? Definitely. If we write a single compound in different ways, I mean, we have in chemistry, we have three different type of structure representation, right? So in last classes we had that. I mean, line structure, complete structure, and the condensed structure. So if we change just a single molecule in the compound or in any chemical compound, then definitely we see the physical and chemical changes. So I will explain everything. So first we will see what is molecular formula. So here, students, molecular formula is nothing but very simple. Let us take one example, that is glucose. So simply, if I ask you what is the formula of glucose means, what you will say? C6H12O6, right? So this is nothing but the molecular formula. So that means what is molecular formula is nothing but the number of different elements present in the compound. In glucose you can say, in fructose, whatever it may be, right? So the number of, that might be a carbon, that might be a hydrogen, or it may be a oxygen, whatever it may be, but the number of elements present in different forms, total number we can say, that is nothing but the molecular formula, right? So if I say what is the molecular formula of water means, what you will say? Water molecule, right? Water molecule means what you will say? H2O, like this. Ammonia or amine or ammonium. If I say ammonia, then what you will write? NH3. Why? Because there is a NH3. I mean, ammonia is having a molecular formula like N and H, where N is 1 and H is 3. Right? So, like this. And if I say sodium chloride means, what is the molecular formula of sodium chloride? That means definitely will give me an answer, that is NaCl. One is sodium and one is chlorine. Right? So molecular formula means again the number of elements present, the total number of elements or different elements present in the compound. So that is called as molecular formula. But in isomerism, that molecular formula must be same. I will show you one example here, students here. So you just see, then you come to know. See, in definition, what we had in doubt, that is with molecular formula. Already we saw now molecular formula, physical and chemical property. So physical, next is chemical property. So if molecular formula means you can know. So I will just show you example. You just listen here. CH3, CH2, CH2, CH3. Now CH3, CH3, CH3. See first about molecular formula. So what is the molecular formula in first case? You just see first and second you consider like this. So now 1, 2, 3, 4. So there are 4 carbon atoms in this compound. So you just simply write 4 carbon atoms. And now count the hydrogens. So that will become, that means the total number of elements present in the different elements present in the compound. So that means there are 2 different elements here, carbon and one more is hydrogen. So already we have counted the carbon atoms. Now you try to count the hydrogens. So 3 plus 3 6, 6 plus 4 10. So that means this is the complete molecular formula of this compound. What is that? There are 4 carbon atoms in this compound and there are 10 hydrogen atoms. So this is about number 1 case. What about this? You just count it. So again 1, 2, 3, 4. Carbons are 4, right? And now how many number of hydrogens? Again there are 2 different what elements. So 3 plus 3 plus 3 9, 9 plus 1 10. So that means hydrogen are also same. See the magic now. They are having same molecular formula but differ in their physical and chemical properties, right? So now I think you come to know how they have same molecular formula, right? So now I am just going with the definition. Again, I am repeating you, don't be confused. I am not going in detail. I am just going with the difficulties in the definition. So molecular formula, they must and should have same molecular formula, but differ. They must and should differ in their physical and chemical property. Then only one we can call them as isomerisms, right? So now see, first I will give you a difference. See, compare the first compound with second. There is a big difference, right? So now, what is that big difference means? In the chain, in the straight chain, you consider the first one. In first case, in straight chain, how many carbons are there? I am just going with the physical now, physical changes. Physically, how this compound looks like, right? In first case, there are 4 carbon atoms in a straight chain. Very important. What about this? In straight chain, there are only 3 carbon atoms, right? This is the first physical change. One more physical change you can say. Here in first case, there is no substituent group. I mean substituted group or branch we can say. There is no branch over here in this case, but here there is a branch. Right? Is there any branch here? No. There is a branch here. These are the physical changes, right? Same molecular formula, but they differ in what? Physical and chemical properties, right? So now, in this compound, I mean, first compound physical property is different than the second compound. Why? Because in single chain it is having 4 carbon atoms, but here in this second case, in straight chain we have only 3 carbon atoms. Is there any branch in this first case? No, but here we have branch. So this is the physical change. Okay. Point is noted. Now molecular formula we came to know and the physical changes we came to know. So, and one more thing what we can say is, if If in chain is bigger, then it will be very strong. As in physical change only one we can say this also, right? So coming to chemical properties, see. So in chemical properties, definitely in chemistry one we can say, right? So the first difference, what we can see over here is with respect to chemical changes. Now we are seeing chemical changes. So now in a straight chain, there are three sigma bonds, and what I said, if the number of sigma bonds are more, then definitely the bond breakage will be very tough or bit tougher. And now, in second case, the chemical change, you compare this. There are only two sigma bonds. Two sigma bonds means to break this compound we require more energy, or to break this compound we require more energy. Definitely, for first compound we require more energy to break. Why? Because in a single straight chain we have three sigma bonds, but here in this case only two sigma bonds. If chain length increases, then definitely I have already explained you. So if chain length increases, then definitely the strength of that compound will also goes on increases. So right, I hope you understood this, right? So isomerism is nothing but they have same molecular formula, but they must differ in their physical and chemical property. Now already we have saw what are the physical changes compared to with the same molecular formula, right? So even though they are having same molecular formula, then also when we can say there is a change or there is a difference in their physical as well as chemical properties. So this is about the definition of isomerism. So next moving to the isomerism. So isomerisms are basically classified into two types. Number one, structural isomerism, and number two, stereoisomerism. Right? Structural isomerism and stereoisomerism. After having a definition of isomerism, now we are moving towards the classification of isomerisms. There are two main classes of isomerism. One is structural and the other one is the stereoisomerism. So we will define and then later we will see the sub classification of structural isomerism and the sub classification of stereoisomerism. So let me now start the first one, that is structural isomerism. So once if you know the definition, then for all isomerisms the definitions looks like same. So structural isomerisms are the group of compounds, these are the compounds having same molecular formula. The definition is same, right? Having same molecular formula but differ if they differ in their structure. Right? Just now we had an example. If they differ in their structure, then definitely those compounds are called as, right? Those compounds are called as structural isomerism. They must and should have same molecular formula. That is the condition for isomerisms. They must and should have same molecular formula, but they must differ in their. If they differ in this, in particular in their structure, then definitely those isomerisms are called as structural isomerisms, right? So these structural isomerisms are again classified into four types. Right? Before going to four type, I will just write the definition so that you can come to know the meaning, right? These are the compounds having same molecular formula, but if they differ in in their. Structural means in their, but they must and should have a difference in their structure. In their structure, then those compounds or those class of compounds are called structural isomerism. You can see or you can get this definition in your any book. I mean, SSLC book or in your 9th book or in first year book. You can get this. But the thing is, we need to understand the concept. So again, same molecular formula, but if they differ in their structures, right? Last example only we had, right? So if they differ in their structure, then those are called as structural isomerisms, right? So these, if you want, you can take this definition, or else you can have the definition of your book, right? No problem. But the understanding concept is very important. So once if you understood the concept, then it will be very easy. So structural isomerism. So structural isomerisms are further divided into 4 classes. One is chain isomerism. Chain isomerism, we will see one by one later. Second one, position isomerism. Third one is functional isomerism. And fourth one, last one is metamerism. There are 4 classes of structural isomerism. One is chain, position, functional, and metamerism. So first we will directly go with the chain isomerism. So dear students, I will try to solve all these in the same class if possible. Otherwise, you will see the classes in position, functional, and metamerism in the next class, right? So now let me complete the chain isomerism. So these are the class of structural isomerism. Why serious? Little bit the definition will change now. Why? Because the chain isomerism comes under the class of structural isomerism. So that's why these are the structural isomerisms. Chain isomerism is nothing but these are the structural isomerisms having same molecular formula if they differ in their chain. Right? Already we saw one example, but I will show this time the different example. So if they differ in their chain, having same molecular formula, but if they differ in their chain, then definitely those compounds are called as chain isomerism. So see, CH3, CH2, 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 CH3, CH3, CH2, CH, CH3, CH3. So now, first our duty is to count the number of carbon. Why? Because there are 2 different elements in both the compounds. So that's why first we will count the number of carbon and later hydrogens. So whether our compound is correct or not, or whether it is isomerism or not. So that means to be a isomerism, the compound must and should have the same molecular formula. See, first we will count the carbons 1, 2, 3, 4, and 5. So 5 carbon. Now count the hydrogens 3 plus 2, 5, 5, 7, 7 plus 3, 10, then 10 plus 2, 12. That means the molecular formula of the first one is C5H12. So now try to count here also the same, right? First you count carbons 1, 2, 3, 4, and 5. So there are 5 carbons, right? Now hydrogen. 3 plus 3 plus 3, 9. This one 10, 10 plus 2, 12. Right? I will again define now. Chain isomerism is nothing but it is a class of structural isomerism having same molecular formula if it differ in their chain, right? If it differ in their chain, then those are called as chain isomerism. So now see here the chain. The straight chain is having 5 carbons directly, but here the straight chain, you leave this, right? This is a branch, you can say. So if you see the straight chain of these, I mean they are having same molecular formula, but see the difference. Here in case of this, in straight chain only, they have all the 5 carbon atoms. But here in this case, in chain, we have only 4 carbon atoms. Like this compound or such compounds are called as chain isomerism. They have same molecular formula, of course, but where they are having a difference, they are having a difference in their chain. In one chain, even though they are having same molecular formula, in one chain, one we can say 5 carbon atom directly attached, but in other chain, what is there? There are only 4 carbon atoms are attached. So that's why one we can say here the in chain there are that means they are very well differ in their chains. So dear students, this is all about today's class. So in the tomorrow's class we will continue with the position, functional and metamerism. So those classes are very important again. So during the next session we'll complete all the isomerisms. Thank you.